Dealing with awkward numbers and bonding. Dealing with awkward numbers in bonding. What you're going to be able to do when you see this is, one, appreciate that I've been growing up with this lady my whole life. But we have a unique situation in Canada. We have $2 and $5 bills. Now, of course, $2 coin and a $5 bill. And this sets you up perfectly to be able to balance equations and compound creation because you've already had experience with this. And I know you can do it. Many bonds are easy to figure out. If you wanted to do sodium and fluorine, for example, sodium is +1, fluorine is -1. So there's only one way for them to go together, 1 to 1. Magnesium fluoride, on the other hand, magnesium is +2, fluorine is -1, so the formula is going to be MgF2. What happens when the numbers are odd and even? Not to pick on math teachers, but I will. In life, we are often faced with terrible dilemmas like the leftover battery. The appliance you're going to use needs 3 and the battery's coming back to 4. Why do they do this? Are they crazy? So a math teacher comes up with what they think is a really practical math problem. Mr. Nerdlinger wishes to buy calculators for his math class because he doesn't realize cell phones exist. But the batteries come in groups of 4 and the calculators come needing 3 batteries per calculator. So how many calculators and batteries must Mr. Nerdlinger buy so he can completely use up his battery supply without any waste? And the answer is none. Batteries are a choking hazard. Are you stupid? You don't give batteries to kids. You buy solar-powered calculators. So I don't know why math teachers think that's a practical problem. But in all honesty, science teachers are bad too. We say things like, without chemistry, life would be impossible. As if that's going to make you study chemistry. The whole point is, my body does that automatically. I don't have to know about chemistry to digest, and I don't have to know how the sun works to get a suntan. So, yeah, I'm picking on math teachers, but science teachers are equally bad at coming up with specious reasonings to justify something. We're going to do this because it's cool. So, if we were to take the math teacher seriously on this question, the only time these would overlap is if you bought 3 packs of batteries for 12 batteries and 4 calculators would use up all the batteries and calculators with nothing left over. Even if we had packs of 7 batteries and the calculators took 8 each, then 56 is the common number they land on. Just multiply the 2 numbers together. That's the first number where they will actually have the same. So let's move on. Defacing money is wrong. I do not approve of this. But this man, this prime minister, is apparently a shapeshifter because by changing his hair, you can make him look like anybody on the planet. So when I was growing up, he was always being turned to Mr. Spock because Star Trek was in. Now, lately, it's been Mr. Severus Snape, not Mr. Snape. So we have this dilemma. We have $2 coins in Canada and we have $5 bills. We've learned to make change this way. But our good friends to the south have had less experience with this. So let's teach an American to make change with toonies and fivers, and in the process, make it quite transparent that you can do this in chemistry because you are a Canadian and you can break a toonie for a 5. All right. So let's start off this teaching an American how to make change with toonies. Hi, I'm a stereotypical Canadian. I like to say a boot and have maple syrup with everything. Is there any questions you have for me? Yeah, I got a big one. I'm visiting here, and I just wanted to make some change with money. Would you like some maple syrup? No, stop interrupting. I don't want any maple syrup. It's good. No, I want to talk to you about these things. This and that. What the heck is wrong with you people? How the heck am I they already made me buy this colored Monopoly money. How am I supposed to make change with these polar bearinos? They're called a toonie. I don't care. How am I going to make change? It's simple. The common number 2 and 5 are going to land on is 10. So if I give you 5 loonies, you'll give me 2 5s. Maybe. What if you're going to take my 2 5s and give me 5 of those loonies? Yeah, and it'll be the same. I'll take that deal. The stupid boy doesn't know that my money's heavier now. I got him. I'm not so totally certain you understand this yet. Let's move on to another situation. See? 2 5s and 5 2s. Well, I said that backwards. 5 2s and 2 5s are the same thing. I don't know, Sonny. I just want the heavier stuff. Now, I've got another bone to pick with you. This thing. What am I supposed to do with this thing? So you come here right now and put your dang hands down. You're not under arrest. Oh, sorry. And stop apologizing. What the heck is that? Oh, it's a threenie. There's no such thing. Oh, absolutely. That's a threenie. Oh, okie diddly. They make it at the Canadian Mint. You can buy it, but it's going to cost you a lot more than $3 because it's a collectible coin. But yeah, we have threenies in Canada. Then what am I supposed to do when someone comes in with a threenie and I have a toonie? So you're saying if I had threenies and you had toonies, how would we make change? Yes! You need some strange money here. Okay, just follow on my handy placard I carry around. What we're looking for is a common number between 2 and 3. It's 23. No. A common number that they both count up to. 2, 4, 6, 8, 3, 6, 9. Or you skipped over one. No. 3, 6, 9, 2, 4, 6. 6. There you go. 3 toonies will give us 6. And 2 threenies will also give us 6. Try some maple syrup. It'll help. Trust me, it's brain food. Look. Wait. Jump into your hose fast. I think I got this Canadian money figured out. Let me see. You're saying if I give you 3 of these and you give me 2 of these back, it'll be the same amount of money. Abso-diddly-lootly. That's fantastic. That maple syrup is a miracle. Well, your brain is powered by sugar. This is amazing. I can figure this out now. That's excellent. Thank you very much, Mr. Mountie. You're welcome. Okay. Now, let's take a look at it in the terms of chemistry. Here's our toonie. Here's our threenie. How do we solve this one? Magnesium's going to donate 2 over, but nitrogen wants 3. So 1 to 1 doesn't work. We go 2 to 1. Nitrogen's happy, but magnesium doesn't work. So we'll add another nitrogen. And it gets stuck. There we go. And now the magnesium is complete, but the nitrogen isn't done. Is this going to end? Wait a moment. Oh, it did. It ended. 3 magnesiums and 2 nitrogens. So you thought the story about the Mountie was pointless waste of time. Oh, no. The toonies and the threenies work here as well. 3 2s is the same as 2 3s. Once you get this, the gates of chemistry are open to you. So the only way you could make magnesium nitride is 3 magnesiums and 2 nitrogens, Mg3N2. 3 2s is the same as 2 3s. Now, what if I was sadistic? I was one of those cruel teachers. And I said to you, I don't really like you, so I'm going to give you technetium nitride. 7 against 3. Do you really want to have to draw this one? Do you think I want to mark it? When will 7 and 3 land on the same number? 7, 14, 21, 3, 6, 9, 12, 15. Oh my gosh, it's 21. It's going to be huge. It's going to look like this. I don't want to grade this, and I don't want you drawing it. It's going to take 7 nitrogens and 3 technetiums. Look at it. If we go up by 3s, we reach the number 21. If we go up by 7s, we reach 21. So we're going to need 3 7s and